Hi there, my dear machine learning engineers, how are in this whole universe? Hope to this fine, I'm a Rashman who being followed through my own experience. And today we are discussing with you about robust clustering algorithms and their appliance and implementation into the different spheres of our life, in different industries, especially in SportTech, MarTech, FinTech, and etc. Okay, first of all, in SportTech, how to use it. Actually, when we talk about sports and athletics and things of this nature, when we do biomechanics of our body, then we have the data. As in any type of industry, we can find the data. And what's by the way, what's clustering? We have the x-axis, y-axis, and imagine that we have a lot of dots inside of this area of plane x and y. And then we need to group objects together. So some similarities will be found, and some data points will be similar to each other more, so it is one cluster. Another cluster, it is when other dots they are kind of similar to each other. And the same with any type of cluster. So any cluster should be connected with similarities, and two different clusters, they are different from each other. So the length, the distance, the Euclidean distance or Manhattan distance or Mahalanobis distance could be different, and could be because one person is looking. Okay, and so we have the Euclidean distance or any type of distance that is connecting them. We can measure it, and to find the distance of similarities, dissimilarities between different types of points. So right now our goal is to make it robust. What does it mean, robust? Robust means that we have the data. Yes, we have here's the data, here's the data, and we have some points that are super mega outlying out of main distribution of data, and we need to kind of find out is this data corrupting or doing something bad for our main data. If yes, then it is outlier or anomaly or out of distribution data that we need to eliminate, delete, remove, and kind of kick out of our main data set of data, or decrease the influence of this data when we calculate aggregation functions. Aggregation functions, it is when we calculate mean, median, or mode from the main data, and different types of compositions of functions of that I said before. Right now we will run two because we have the person. So because we have the machine learning talk with you. Actually, one more person for machine learning talk, it will be good enough too for us. So let's go there. we have everything is fine. Okay, and about robust clustering. Yes, robust clustering is when we collect the data and we have some points that are super dissimilar to the main distributions of data. It is kind of one more cluster, but the cluster that we don't need, noises for example, exaggerated data, or maybe some, if you do some review of questions, interviewing people on the streets, and you have some of the distribution of data, you have the median and mean number of this, and we have something that is super far away from our main distribution, kind of 3 sigma rule is out of it, and kind of like this. And if we have data that is out of the main distribution, that we need to delete it, because when we calculate aggregation functions, then something will be maybe changed. The center of the cluster could be kind of switched a little bit, or maybe middoid could be switched, because sometimes middoids could be calculated from centroids, and actually if centroids is wrong, then middoid could be 2. So right now we are talking about appliance of robust clustering, because we talked about our clustering, also about robust clustering, and right now how to apply it, where to apply it, what's the applications areas that we can find in our life to discuss about robust clustering. Oh, interesting. It fell from this tree. Binary tree. No, it's KR tree. Kind of. Or we can calculate how many the different twigs inside of it. Okay. our appliance implementation of robust clustering algorithms to the specific areas. In terms of the athletics, in terms of the sport tech, we can apply it to the biomechanical data. Biomechanical data of pos.x, pos.y, pos.z, vel.x, vel.y, vel.z, ac.x, ac.y, ac.z, which means to us it is position, acceleration, and position, velocity, and acceleration in terms of the x and y and z coordinates, x-axis, y-axis, z-axis, and actually it is our things that we have. Oh, geez, phoning something again. And we have different types of measures in terms of the points. The points, for example, in our soleus, gastrocnemius, or abdominal muscles, or maybe it will be for trapezoids, deltoids, and different types of muscles that we have in our body. Latissimus dorsi, and we have points, and we have centers sometimes of these muscles in terms of the kind of the center of mass. Yes, and we can calculate it, and when we calculate it not correct, then other data could be switched, corrupted, and kind of not really nice that we need actually. And actually we need to eliminate these situations when we have the wrong centers, the wrong aggregation functions, data that we got from aggregation functions, and when we delete it, then aggregation functions will be calculated correctly. So it is all about our things. Next, it is in our athletics, in SportTech, we have not only the direction of biomechanics, we also have the direction of different types of colors, because colors sometimes represent to us, if we have the visual data of OpenCV, for example, library, or something like this, we have the visual data of pixels and RGB, RGBH, CL, HSV, HSB, CMY, CMYK, colors models that we have to describe our colors. And sometimes we have this switch from the main colors. So I imagine that we have 255.00, it is the red color, and we have 249.00. Actually, it is almost the same color, but accuracy matters, because 1% in terms of the, for example, accident. For example, if somebody will hit another person, or maybe on the finish line when you finish your marathon or ultra marathon, or maybe some sprinting distances of 60 meters, 100 meters, 200 meters, 400 meters, then if you will collect the data from the finish line not correct of the color that you have of the person that is finishing, then it could be kind of the mistake, and it could say that Jesus Christ, you finished a little bit later than another athlete that we have that calculated correctly. And actually it matters, because I said already, the data from 2 milliseconds in this type of things matters. The same with other directions. I imagine that we have auto driver car, driverless car, and you are moving, and kind of a little bit centimeters could be they could matter a lot for us. So it is about our colorful things. Also, from another data we actually can get it from different types of speech. It is word-to-vec, doc-to-vec, the type of things, vectors that we got from the words, sentences, from different types of documents. Yes, kind of. And we have this, and actually it is one more thing that you can get information from different types of textual data. And actually, because of the textual data, kind of words that athlete said, oh Jesus Christ, beautiful, look at this. And And maybe need to do photo after that, after I shoot video. Yes, and you have the data from the set words, the words that were set, and actually you can find the centers here to aggregation functions too. And robust clustering helps us in this direction too. So it is about SportTech. Also in MarTech you use it the same. In MarTech you use it by using textual data. Actually we have written words, photos, videos, and audio. It is the 4 main domains of our perceptual information that we can get from the data, and then we have the numbers, and we calculate the numbers using different types of Gaussian, Hessian, Laplacian, Lagrangian, Weierstrass, using Lindemann, Weierstrass theorems, and other directions. It all depends on the direction that you use it actually, but okay, you can use any type of things, and actually you will find out something interesting as we found this heart on the snow. So thank you a lot for watching this video. Improve Solidity, go forward. You are a nice machine learning engineer. Go forward, create, build, make, construct, develop, design, invent, originate. Do sport exercises, do facial exercises, do breathing exercises, do vocal exercises. Improve Solidity, because machine learning engineers, it is not only about the technical stuff. Yes, it's about technical stuff, but also it's about the soul, about the people, and about the growth that we have. So thank you a lot for watching. See you next time. Improve Solidity. Bye bye.